Carnegie Institution for Science audio press release for August 2, 2012. Fingering the culprit that polluted the solar system. For decades, it has been thought that a shock wave from a supernova explosion triggered the formation of our solar system. According to this theory, the shock wave also injected material from the exploding star into a cloud of dust and gas, and the newly polluted cloud collapsed to form the Sun and its surrounding planets. New work from Carnegie's Alan Boss and Sandra Kaiser provides the first fully three-dimensional models for how this process could have happened. Their work was published by the astrophysical journal Letters. Traces of the supernova's pollution can be found in meteorites in the form of short-lived radioactive isotopes, or SLR Eyes. SLR Eyes, versions of elements with the same number of protons but a different number of neutrons, found in primitive meteorites, decay on timescales of millions of years and turn into different so-called daughter elements. A million years may sound like a long time, but it's actually considered short when compared to other radioactive isotopes studied by geochemists and cosmochemists, which have half-lives measured in billions of years. When scientists find the daughter elements distributed in telltale patterns in primitive meteorites, this means that the parent SLR Eyes had to be created just before the meteorites themselves were formed. This presents a timing problem, as the SLR Eyes must be formed in a supernova, injected into the pre-solar cloud, and trapped inside the meteoritic precursors, all in less than a million years. The telltale patterns prove that the relevant daughter elements were not the ones that were injected. This is because the abundances of these daughters in different mineral phases in the meteorite are correlated with the abundances of a stable isotope of the parent element. Different elements have different chemical behaviors during the formation of these first solids, and the fact that the daughter elements correlate with the parent elements means that those daughters had to be derived from the decay of unstable parent elements after those solids were crystallized. One of these SLR Eyes, iron-60, is only created in significant amounts by nuclear reactions in massive stars. The iron-60 must have come from a supernova, from a giant star called an AGB star. Boss and Kaiser's previous modeling showed that it was likely that a supernova triggered our solar system's formation, as AGB star shocks are too thick to inject the iron-60 into the cloud. Supernova shocks are hundreds of times thinner, leading to more efficient injection. Now Boss and Kaiser have extended those models to 3D so they can see the shock wave striking the gas cloud, compressing it, and forming a parabolic shock front that envelops the cloud, creating finger-like indentations in the cloud's surface. The fingers inject the SLRI pollution from the supernova. Less than 0.1 million years later, the cloud collapses and forms the core of the protostar that became the Sun and its surrounding planets. The 3D models show that only one or two fingers are likely to have caused the SLRI pollution found in primitive meteorites. The evidence leads scientists to believe that a supernova was indeed the culprit. However, more detective work needs to be done. Boss and Kaiser still need to find the combination of cloud and shockwave parameters that will line up perfectly with observations of exploding supernovas. The Carnegie Institution has had over 110 years of extraordinary discoveries. To continue this tradition, Carnegie scientists need your support. For more information about this and other cool science, visit our website at carnegiescience.edu. This is John Strom.